Okay, welcome to Unit 3. We're going to be talking about heat in Unit 3. The first activity is a little convoluted. Actually, the first two, they jump around a little bit, so I'm going to try and get you going in the right direction. Let's just talk about things that give off heat and things that talk about heat. If we have something like a campfire, that's exothermic. It's giving off heat. There's two ways that we can write that. One way to write an exothermic reaction is to put plus heat on the right hand side. So that would be like plus 36 kilojoules. The heat is measured in joules. A joule worth of energy is like taking a 5-pound weight and lifting it up 1 meter. I know it's hard to visualize what a joule is, but if 36 kilojoules is written on the right hand side, that's an exothermic reaction. The other way to write an exothermic reaction, that was number one, this is number two, is to say that the delta H, which is the enthalpy, we call it the enthalpy of the reaction, is a negative number, like negative 36 kilojoules. So if you put the delta H and it's negative, it's exothermic, or if you write it right in the equation, it's exothermic. Now, reactions that are endothermic, what they do is they absorb heat. You must go, well, you must think, well, that must feel hot too. No, it feels cold because the heat is hiding inside of the bonds. So if you imagine a glass jar and you put two chemicals in there and it is endothermic, they absorb the heat from their surroundings, making their surroundings feel cold. If you see the heat written on the left-hand side, that's endothermic. Or if you see delta H equals a positive number like plus 36, that's also endothermic. Now, they go into nuclear reactions in U3A1 as a type of reaction that gives off heat. I'm going to leave it up to you to make a chart up on alpha, beta, and gamma radiation, just so you can see what they do when they're balancing. The mass number is 226 on the left-hand side, and it's 222 on the right. That means we're 4 less here. So I need to be able to put a 4 up here. Now that 4 could be neutrons or protons. It doesn't matter as long as the 4 plus the 22 equals the 226 on this side. When you look down here, this is the atomic number or number of protons. On this side you've got 88, on this side you have 86. You need 2 more over here. What element has an atomic number of 2? That is helium. This will be an alpha decay, and we know it because we've got an alpha particle in there, which is helium. When you do this actual content, this will make a lot more sense. I'm just showing you the balancing aspect here. Okay, we know we have beta decay because we've got an electron here. Once again, all we're doing is the balancing. It's up to you to figure out what the alpha, beta, and gamma radiation are. I would watch a couple of YouTube videos and make good notes. We've got 0 over here and 234 over here. So 0 plus what gives us 234? 234. And over here we have a 90 and here we have a minus 1. What plus minus 1 gives us 90? That's going to be 91. So if we look up the element that has an atomic number of 91, we would find that this is the element right here. All I've done here is I've worked on the balancing aspect of things. The big thing that you have to do with U3A1 is you have to understand how we write reactions that give off heat and how we write reactions that absorb heat, and then know your 3 types of nuclear radiation or decay. The bigger the particle, the less dangerous it is. So this is alpha decay. It's a nucleus of helium, and this one here is beta, and it's an electron, and the gamma will just be wave or radiant energy coming off, and it's the most dangerous.